Hello. Okay. Hi, everybody. Thanks for joining this workshop, and my apologies for the confusion on the time. We saw there was 2 different times posted, so we just wanted to give everybody an opportunity to show up. My name is Raphael Mudafort. I'm a researcher at NREL, and my colleague Derek Slaughter and I are going to host this workshop. This is a workshop presenting the portfolio of software tools funded by WETO. And so it's not necessarily NREL tools, but primarily tools developed at the national labs funded by WETO. So this is just a graphic of all of the software tools covered under this umbrella. And you can see there's quite the breadth of these wind energy tools coming from the U.S. Department of Energy National Labs. And because of this breadth, the scope and intended use of each, and especially as they relate to each other and to the whole, can be quite complex. So we've recently been engaged in work to add some clarity to this topic, and the recent findings of that work and the upcoming work are the subject of this workshop. Here's a general agenda. First, I'll just introduce this project that we had over the past year to do this mapping. And then we'll go through the software portfolio in some detail, and I'll present some web-based tools that we've made to inspect and analyze this portfolio of software. And then at that point, we'll stop and we'll answer any questions, take a brief break. And then we'll come back and I'll give an idea of where we're going in the next couple of years in this regard. So around this portfolio mapping and planning project. I'll also briefly talk about our expectations around internal and external software development, quality and standards. And I'll just mention what we're doing as far as the user community is concerned in the next year. And then finally, at the end, there will be another opportunity for discussion, as well as just another opportunity for questions, as well as an open-ended discussion. And I've got a question for you, the community, to seed that. All right, so to start and for context, the primary funding mechanism for wind energy research in the U.S. is through the U.S. federal government's Department of Energy, and specifically the Wind Energy Technologies Office, or WETO. WETO manages the DOE wind energy program. And WETO's mission is copied here. This is a screenshot of their website, and then over there, the mission is copied. It's quite long, so I'm not going to read it, but I will summarize it just to say that WETO invests in wind energy research, development, demonstration, and deployment activities that enable and accelerate the innovations needed to advance wind energy. However, that middle section there in 2023, the research, development, demonstration, and deployment in today nearly always involves some sort of modeling software and oftentimes software development. So in my personal opinion, and this isn't to say that WETO would say this, but I might rephrase this as WETO invests in wind energy software that enables and accelerates the innovations needed to advance wind energy. And this is evident in the breadth of software shown in the first slide, as well as the quantity of national labs that are involved in developing these tools. These are just some of the labs that primarily contribute to the WETO software portfolio. Now, WETO's mission, combined with the current set of software projects, results in the need for some sort of coordinated planning and development to make effective use of all of our efforts. So to that end, we've been engaged in what we call the Holistic Modeling Project to map, analyze, and coordinate the ongoing development of these tools. The Holistic Modeling Project is actually quite big, and this coordination and portfolio planning is one part of it. So just to give some context here, this is the objective of the Holistic Modeling Project. So on the left here, I've got just a representation of what is kind of our current state of how the software tools relate to each other. They're generally fairly loosely related. We have an intuition on the physics captured and the fidelity and how we might be able to use these combined. So in this case, this might be putting the cart before the horse, but we have some tools that all might do some sort of aerodynamics: OpenFast, VEXO, Stack, and Florus. And they can certainly be used together in various ways, but we don't have a great way to communicate those relationships outside of code. And so that's what we're trying to move to. We're trying to move to something closer to on the right, where we have a kind of an architecture of our tech stack, where we can show and communicate connections. And so what I'm just prototyping there is the solid lines might represent a direct connection in code between something like Exawin and OpenFast, but an indirect connection. So you might use one in the workflow of another to kind of complete some larger task. And that's generally the sort of coordination that we're trying to get to. Same thing with the graphic on the right, where we have a variety of aerodynamics tools, and we want to just relate them to each other, in this case, on fidelity, and the analogous there is computational costs. So we want to, compare and relate based on various attributes: funding level, release activity, documentation maturity, physics, and the primary use case. Now, just briefly, the Holistic Modeling Project is a 3-year project. We just finished the first year, and it really was primarily around getting the data in place and engaging with model owners, so establishing a model owner community. The current year, year 2, will involve putting into place a lot of the frameworks and methods that we developed in the first year and engaging with the community of users, which is probably this community. And the final year will involve additional portfolio streamlining and putting a coordinated roadmap into place. So now getting to more close to the subject of this workshop, in the past year, we aggregated data, spoke with many stakeholders, and created the basic tools that we'll continue to build on in the next 2 years. We created 2 websites and to list and inspect the portfolio of projects. And we've proposed a set of best practices for software development under the WETO umbrella. And we started to evaluate how we can manage to keep so many projects in sync at a time. Just one thing to note is that we developed the processes and frameworks to do these things in the first year, and then in the next couple of years, we're really putting them in place. So a couple of the things that we developed, a couple of the tangible products were these 2 websites. They're both software listings, but they have a bit of different information in each. The one on the left is what we're calling the Code Hub, and this is on the A2E website, which is a Department of Energy website. And then the one on the right is a more static listing, but it has a bit more. We have a bit more control. The one on the left is auto-generated, and the one on the right, we have a bit more control to add content here. And that really is the dashboard for this project over the next few years. And now I'm just going to demonstrate or just walk through these very briefly to kind of show what they can do. So this is the Code Hub listing. And like I said, initially, this is really just the first pass, and we're going to continue to build on it. But this gives you various information. It scrapes all of this information from GitHub, and you can see a timeline of code contribution. So this gives you an idea of how actively this project is maintained, how many contributors there are, the number of forks. All of this stuff gives you an idea of community engagement. And then you can also start to see, you can sort by language if you're interested in the license and where the project is stored under which GitHub organization. And at the moment, this is fairly simple, but this is a good framework to start building up and adding more metrics to filter on. And that's the plan for this fiscal year on that. Now, this other website is the WETO software stack that I mentioned. This is the dashboard for this holistic modeling project. And it's got 3 high-level areas. One is the first one is just an overview of we had a model owners workshop in September here at NRO. And you can see the agenda for that workshop here, as well as an extensive workshop report that my colleague Garrett Barter put together. So I highly recommend going through that. There's a lot of good information there and really gives an idea of how the software model owners are thinking through their tools and kind of the state of the portfolio as a whole. The second section is the portfolio analysis, and I'll only show the software listing now, and I'll come to the other areas later on. But the software listing, again, has this big map of all of the software tools, and then a list of, it has two lists of software tools. First are the ones that are actively supported and in active development by WETO. So this list of tools is what makes up this map that I'm going to show again and again over this presentation. Now, the other section here is just vaguely titled Other Status. And these are, this is much more expansive and comprehensive. And these were all the tools that I could find that had something to do with wind energy. So many of them are not funded by WETO. Many of them are not funded at all. Many of them are deprecated. And you might have a hard time finding the executables or the source code to use. But this is meant to be kind of the really, this plus the active support list are meant to be the comprehensive wind energy software tools somehow related to WETO. So I highly recommend going through this. And finally, there's a list of research software best practices. This was compiled into a report that will be published soon, but this is still a living document here on this website. And I'm not going to go through it in detail, but there is a summary of all of the best practices. And if you're interested in software development or planning a project, I highly recommend reading through this, or at least picking specific sections and reading through them. And then finally, before I leave this page, the last thing I'll say is that this is on a GitHub repository, all of the documentation for this website. So you can go to this little GitHub icon and click repository. And if you have anything to contribute or want to modify anything, if you have a software tool that you think should be listed and it's not, make a pull request. And I get the emails and I'm happy to review them. And I really hope that this can be a community resource. Okay, now let's dive into the set of projects. So for the sake of narrowing the search space, we chose specifically to consider the subset of WETO-supported subset of WETO-supported software. And I already mentioned this, these are tools that are actively funded, are in active development. And the kind of one nuanced piece is that they have a significant user-facing component. So while this filters out plenty of one-off tools for individual analysis, such as like any scripts for a paper or for a small project, and we want to filter those out, this also is kind of a catch-all, and it filters out some more important tools like any of those that manage any of the data, like the Wind Toolkit, which is a very popular data set and has a lot of software behind it. That software is not tracked here. We also realized earlier that the Awaken project probably has a lot of software that isn't tracked here. So this is quite limited, but with that caveat, we can take this set of tools and start to look into start to develop a map of the software portfolio. And then the intention is that over the next couple of years, we'll start to add some more of these tools and build out the rest of the portfolio. Yeah, so now we'll start to look into the individual technical areas here and actually list some of the tools. So the technical areas that are in this big map, these are these blobs here. All of the tools have the more square edges, and then these blobs, of course, excepting the WETO software portfolio one. These are all these categories that we've divided these into, and so we're going to step through each of those. All right, so the engineering fidelity physics models, these tend to be tools that balance, that find a balance between accuracy and computational costs or efficiency. They're engineering models, so they're simplified models that typically start from high fidelity models, or at least are informed by high fidelity models. Some of the more common ones here that you probably have all heard of are OpenFast and FastFarm, but there's also a few others, MorePy, a digital twin package, Raft, and AMBA4. And these are all, I presented this section first because these tend to be embedded in a lot of the other tools that make up the software portfolio. We also have high fidelity models. these consist of also some that you may have heard of. AMR Wind and NAWEA Wind are the high fidelity CFD models for doing blade resolve simulations and high fidelity wind farm simulations. OpenTurbine is a new structural dynamics code that it's in active development, and it's designed specifically to couple with both engineering models like OpenFast and high fidelity computational fluid dynamics models. EARTH is it's energy resource and forecasting, and it's a high fidelity weather research model. And WindSC is a CFD code, a RANS CFD code, so also high fidelity, but somewhere in between the engineering models and the high fidelity AMR Wind stack. And then PyNUMAD is a three-dimensional is an interface to high fidelity structural models such as ANSYS and Qubit and OpenFast. All right, so the combination of all of those tend to be coupled with a lot of our design and optimization tools. Some of these are WISE, Wisdom, HOP, and Sonata, and we're going to go over these in a little bit more detail later. But I think the important point here is just to say that these tools tend to be more or less glue codes involving some of their own utilities and tools, and some of the other tools in the stack. We have a controls body of tools. Rosco is the reference open source controller for generic turbines and has generic tuning capabilities. That's kind of become, along with OpenFast, has really become a central tool in the software stack. Floris is a controls-focused wind farm simulation software, steady-state analytical model, very fast, and has just low-order models. Flask is an analysis tool set for SCADA data that integrates with Floris. Hercules is a wind farm emulator for controls testing with LES models, specifically the ExaWind stack, which is the AMR Wind. And then MOA Python is a tool for wind farm performance post-processing. Next, we have the resource assessment section, and in there, as far as the set of tools that's tracked, DWTAP is the only one that we have here, and this is basically a front end for some data sets that people can interact with, and their kind of tagline is that they want to make assessing wind resources easy and without having to physically take any measurements in the field. Then we have a body of cost models, and this is kind of a new-ish area with a lot of development going on. Land BOSSI and hybrid BOSSI are balance of system tools, balance of system cost models for hybrid power plants and land-based wind energy systems. And then Coral is a concurrent orbit for shared resource analysis. And then Narwhal is a library of offshore wind cost equations. Again, these tend to be embedded with some of the systems engineering and design tools. And then we have a relatively new tool for measuring wildlife impacts, SSRS. This is specifically tailored to modeling raptor movement through wind farms and how raptors are drawn to different types of characteristics in the wind, which can tend to steer them into wind farms. So yeah, we'll talk a little bit more about that one. That one's pretty cool. And then there's the O&M section, operation and maintenance, and here we have Wombat and OpenOA. Wombat is a simulation library for operation and maintenance, and OpenOA is a framework for dealing with large time series data from wind plants, such as SCADA data, but it also integrates with, there's also a component of OpenOA that standardizes this data, and this has actually had quite a bit of industry penetration. All right, now we'll transition to, so that was the list of technical areas, and that's one way to divide this tool set. Now, in analyzing this, we thought it would be nice to, well, it's nice to kind of bin these by their maybe physics domain. It's also quite helpful to understand how these all work together to, like, how could you use them to what end? And that's where we develop these capability areas. And to present that, I'm going to pass it on to Derek Slaughter to talk through these.
Good morning, everyone. So we'll start with I'm kind of going to build up from like the basic software that then gets included in later and later softwares, and just give a brief overview of what that is and what it's used for. And naturally, I'm going to start with OpenFast because that is a core for many of our analysis tools. OpenFast is a multi-physics wind turbine simulation tool. It handles everything from time domain analysis to linearization, frequency domain. It handles also all the physics that you would normally see in a wind turbine. So this is at the engineering level. So it's not super high fidelity, but we have things like Aerodyne, which handles aerodynamics. And that's going to include things like BEMT and free vortex wake, uh, that that kind of level of fidelity. Uh, Inflow wind, which is our model or our module for simulating inflow, and that is fed information from TurbSim, which would probably be good to have in this list as well. It's included in the OpenFast repository, and that's can generate inflow grid time series based on IEC turbulence models and various parameters. Then we've got Hydrodyne, which handles all of the hydrodynamic effects. And it's been recently augmented with C-State, which handles waves and currents and that kind of modeling types. Then we've got it handles the structural dynamics. So Elastodyne and Beamdyne. Beamdynes are full geometrically exact beam theory model, which is used for the blades. Servodyne handles all the controllers and interfaces to Rosco, which I'll get into later. Okay. Oh yes. So the third one down on the right is probably should be labeled Elastodyne, which handles the tower, the nacelle hub. It also has a version of the blades. Um, and then Subdyne handles substructure interaction. So like between the ground and the tower, or in this case, the floating platform and the tower. And then MAP and Moordyne handle that kind of the floating anchoring system for the floating platforms. So this handles onshore wind or onshore turbines, offshore floating turbines, offshore anchored turbines, and there's even been allowances made for handling underwater turbines. So it's a really general purpose tool. And then, as Raphael mentioned, Rosco, it's the open source controller for OpenFast. It's a drop-in replacement for the bladed style controller. It's built as a DLL and then interacted with in OpenFast through Servodyne. One of the really great capabilities of Rosco is that it can be automatically tuned for a turbine. Like there's a Python library that goes with it that will figure out what the optimal controller parameters are for a given turbine model. And that's part of another suite as well. Um, then we get into some of the wind farm simulation tools. Included in the OpenFast repository is FastFarm. And basically this takes and creates instances of OpenFast at various locations to simulate a full wind farm. And it handles downstream wake, turbine yawing, and basically it's a higher fidelity than Florus, but it's much lower fidelity than, the AMR wind type of suites. All right, and then we get into Florus, which is an analytical system for designing wind turbines. So it's very fast. but it's not extremely high fidelity. Like I said, lower than OpenFast, but you can do a whole lot of simulations very quickly to get an optimized wind farm layout. So this could be used as like a starting point for fast farm. Okay, then there's MoorPy, which is a quasi-static mooring tool set. This is a Python code that really just handles the mooring lines, the loads, displacements, that system. This is used by later in Raft to do frequency domain analysis of floating wind turbines. And then we have Raft, which brings together a whole lot of physics and analysis tools. So Raft is kind of a subset of WISE, and in this particular case, the design description of the wind turbine floating platform and so on is from WISE, so it will load those files, figure out how to mesh the substructure, generate the full model, and then do optimizations of like the floating platform to give you the dynamics and response that you're interested in or that you're targeting. Yeah. Finally, or then there's Wisdom, which is used for wind plant costing measurement. So you based on, this how big your turbine is, all the parameters, it will give you an estimate of how much that turbine would cost to operate or build or, it's a Python script that is then used by WISE for overall system optimization, and includes a lot of the other tools that Raphael mentioned in the previous section. Or it builds on those and orchestrates them to generate its costing. PyNumad is an evolution of the MATLAB NumAd structural analysis system, and this is used for generating wind turbine blade cross sections and full 3D models. And then this can be used to generate beamdyne models for use by OpenFast. It also works with a whole suite of other software. This is developed by Sandia Labs. Sonata is used for optimizing blade cross section and just doing general design there. 3D surface generation, mesh discretization. Basically, all of these things feed into generating the inputs that go to OpenFast. And then finally, we get to WISE, which is the wind turbine multi-fidelity co-design tool. And this brings many of the previously mentioned tools together, and provides a framework for doing overall wind turbine design optimization. Everything from plant controller, design variables, system component constraints. It's a huge suite, and you've probably heard about it, or you've heard people talk about it quite a bit. So how does all of this fit together within WISE? Wisdom used for figuring out like the rotor drivetrain cost. Roscoe being used with OpenFast to actually do simulations. WISE interacting with Sonata to generate the blade design along with PyNumAd, and all of this coming together to perform wind turbine optimization. Separate from these things, just a little bit about HOP, the Hybrid Optimization and Performance Platform. This is a Python code that's used to figure out how to optimally connect the various, yes,
Sorry, I have a question.
sure.
Show the work that box that's hidden. In distance, there are loads calculations. You start a model or some sort of surrogate model. How do you get loads from each of the over time?
That is a good question. I don't know, Raph, do you have any insight on that?
That's the path.
Okay.
So you have, so anytime you do anything that requires a new code towards evaluation. So the YSB has, I'm not sure on the slide, but it's like 3 levels of difficulty. Open fast is like the highest level. Level here, time-based condition. Craft is like the lowest level. Frequency domain. And then we have like the middle level is called this linearized fast. So you can linearize everything. Like your level. So you can change the 3 levels. You can all generate those of the graphs. We'll get there.
Come on. Oh, no. Okay. Sorry.
Weird computer.
Yeah, it wasn't like responding to clicks.
There you go.
Thank you. All right, like I was saying, the HOP for Hybrid Optimization and Performance Platform figures out optimal ways to connect like generation, whether it be wind, solar, geothermal, hydro, to storage, how to handle controls, and then connect it to the grid. Kind of takes all of these things into account. It's also a framework for including custom models for all of these various levels of or categories of optimization. WindSE is another form of wind farm simulation and optimization. This is I'd say medium fidelity for medium fidelity. RANs, yeah. So adjoint gradient calculation for performing optimization. And then we have our high fidelity suite, AMR Wind, NAWEA Wind, ERF, and Open Turbine. And all of these work together on like our HPC systems to provide, to like couple CFD with structural dynamics, which can either be Open Turbine or Open Fast. And the different like domains, like AMR Wind is can handle a full wind farm and does the flow between the turbines. NAWEA Wind does the flow the um, right around the turbine blades. That's what this is showing. So this domain out here would be AMR Wind. This would be NAWEA Wind. The structural part, like I said, would be Open Turbine or Open Fast. And these are really big models that require a lot of computing resources to run, but this is the highest fidelity simulation system that we have. All right, questions? Yes. Yes. Unfortunately, I'm not an expert in all of these particular tools, so I will try my best.
So NSC is variable. Fast one is really the loads. Not only those calculations, but the whole NSC is like aerodynamic.
I see.
And really tailored there's compensation. I would say it's like a higher fidelity more. It's all like bands. I also do some dynamics. Yeah, Flores and Jordan.
But is it more like openly commercial software?
I don't think it's definitely more of a research slant. I think it is much more like a direct industry. I mean, rest of the this is definitely more like my experience with but yeah, I'm not sure I can compare them that way, but personally, but then, yeah.
Thanks.
Yeah, we also checked with Florida, on the same level, this is probably one level above that, 3D brands. And
2D or 3D brand, you can choose.
Can it handle like terrain effects and can it do irregular terrain, complex terrain?
It does like a grid deformation. I'm not sure. It's brands, it's not usually a little bit of complexities. So you have terrain, like word station all the time. It looks like, yeah, you can build your terrain.
Thank you, Jason.
We tried to organize and bring all these pieces of code and software together. As someone quite new to this, something I've had trouble with other conventional software is just getting it to run in my software environment and getting dependencies and stuff like that. Do you have any kind of plan to sort of maybe have some sort of shared software environment or like Docker container where you can sort of reliably anything from WETO is going to run in this environment that you can reproduce it really quickly?
That is something that we were exploring, especially for WISE. We've had a lot of users complain that it's difficult to get up and running, especially on the newer MacBooks. I'm not sure if we'll be able to incorporate everything into one coherent environment, but certainly the process of getting the various packages installed is an issue that we're aware of and working to resolve. I agree.
One point, just clarify, this was just a midpoint or like a 2/3 point. This good question is on the set of tools and capabilities. And there's 3 more things that we'll talk through, one of which is our the next 2 years of work in this project, which will address. All right. There's no more questions, we'll continue and then
The discussion. Okay, so I wanted to just give an overview. I wanted to go back to these dashboards and give an overview of some of the tools that we've been working on to start to understand how this portfolio relates to each other, like I was saying at the beginning. So I'm going to, these are just 2 screenshots, but I'm going to go back to this website at the top. All right, so here in this portfolio analysis section, again, we've got the listing, which I already talked about. And then there's this software attributes page. I'm just going to collapse the menu here so we have more space. But this, we created a sort of a database of all of the tools. So we listed each tool and then tried to aggregate all these descriptors or attributes of each tool. And this page is the start of an effort to be able to analyze this data. So while it's not very user-friendly yet, I'm going to continue to reiterate it's a work in progress. But you can do things like, each of these sections list all of the tools, and the sections are divided by kind of groups of the attributes. And so you can see the database entry for each tool. And so something in this general section, for example, you could sort based on the primary use for that tool. You could sort see whether it has active funding, which, all these should, and even like data collection methods. And so I'm not going to go through each column, but there's a lot of interesting things here, and we're going to continue to update this database over time with both automated methods to just check on the health of each tool and measure the community engagement, as well as some more manual methods that we're going to update quarterly on things like funding status, whether there's new features in development or it's in just maintenance mode. So one thing I did want to show here is that each of these tables you can use these SQL queries. So you could do something such as, if you drop this down, so from this modeling section, the scope value here, it has, this is, kind of in programming terms and data structures, this is a list. So if you sort it, it's not very it's not very good at sorting it because it sorts it based on the full list, not just subsets of the list. But you could do things like you could filter for any in the scope that have the farm. And then, so that filters all those out. So there's 12 now instead of the 30. And then you could sort based on which have loads. And just start to get an idea of what tools are available for what particular case. And so, like I said, we're going to continue to build on this and try to make it into, try to make this into a tool that we as model owners and program managers can use to understand where we are as well as what's missing. And I hope also that this can be a tool that users can use to, pick your tools. Let's say you're defining some project, some scope of work. You could go to this and use this to pick the tools that you need to do that work. More on the programmatic side, programmatic management side, we've started to compile a list of dependencies, and this is a pretty ugly figure just because it has a lot of stuff in one place, but this is just this is just a graph, a network graph that points to the dependencies between each project. And while it's not really pretty to look at, you can already start to understand which of the tools are at the core of the software stack. Of course, OpenFast, even Wisdom is depended on by a lot of projects. And so this leads to interesting questions around planning the software, such as why is Wisdom a core depended on by so many projects? And if you look into it, it's just for a small part of Wisdom that a lot of projects are using. And so that is kind of the information that enables us to say, okay, maybe we should take that small part of Wisdom out and make it its own library so that you don't have to install all of Wisdom in order to use one of these other smaller tools. This is just another view of the same information. Instead of the dependency, the connectivity, you just get just like a scalar value for each project. And of course, we see the same information that we saw above, that OpenFast is really depended on by most, by a lot of projects. And then you can also infer, since OpenFast uses Rosco, that Rosco is also at the core of this stack. All right, and briefly, I just want to touch on another part of the work from this past year, which was to define these best practices. So even before I get to this, I'll just say that we're doing all of this work for kind of three types of people. One are the model users or the consumers. Another is model developers, and then the third is the kind of program managers. So people at the Department of Energy, even people within the national labs who are more PIs but not doing the work. So we're trying to improve the accessibility and usability of all these tools for all of these stakeholders. So in this regard, the best practices, we kind of split this up into two general topic areas. And like I showed in the website at the intro, the best practices are quite extensive, but you can kind of summarize them by just saying that we're We're trying to improve the usability for practitioners, which are people consuming the software, and then developers. And I'm not going to really dive into the details of all of this, but the kind of short version is just to say we want to, just like you were saying, we want to make this easier to use and remove some of the barriers, with the ultimate goal being that we want to really capitalize on the potential impact of these tools. So we don't, we're not just writing it, developing these just to make new software. We really want it to be used and have an impact. Go ahead. Yeah, that's a whole, I mean, it's that's a difficult thing to kind of coordinate, but that is part of the best practices, that there should be some process of verification and validation, as well as software testing, just stability. But yeah, at a high level, we're addressing this, but at the specific level for the projects, that's really up to their own project managers, PIs.
Heavily focused on primary, just kind of centered that. Estimating and so on, versus a lot of other tools to verify against stuff, like not directly into the B&B campaigns, but they're checking against the other tools. So yeah, that may be nice actually, other linkages to have in your informations.
Oh, which are validating against which? Yeah, good idea.
Easy to say about the Boston, any sense.
Yeah.
But there will be other codes that are perhaps less well known or less cited and less published. Would be useful to have that and get a sense of people want to go to do.
Yep.
Your objective is to get a community to have a GitHub, have opportunities for guidance.
Yeah. Yeah, I like that idea. Yeah, I mean, let's talk more about that if you're around the rest of the day. That sounds like a great idea. All right, and just to wrap up, just to kind of summarize what we're going to be doing in the future. So this year in our fiscal year, which starts in October and runs through September, we're going to be embarking in a user survey. So that'll probably go out to each of you, especially if you registered formally for this workshop. I'll have your email addresses. And we're really trying to create a user community and engage with it. So this user survey will be the first step. We're planning a user-focused workshop in either May or June of 2024. And again, I'll send emails out to this email list, but if you didn't register, then please get in touch with me. My email address is there. And then another major aspect of this is going to be ecosystem streamlining. So just an example of an ecosystem that could use some streamlining. OpenFast is the simulation software, but there's all these other tools that people have developed to do the pre and post processing and actually run the codes. And it's almost just a predictable thing that you come into a research organization, you start building your own tool sets. And that's kind of reinventing the wheel. On one hand, it's good to learn the processes and understand the things going on in the back end. But on the other hand, we have these rich sets of tools that just aren't very cohesive at the moment. And that's one area that is almost low-hanging fruit, just to coordinate the set of OpenFast tools around it. So these are things like PyDatView, if you've used that, which is a visualization tool for the output files. There's a Python toolbox on the GitHub, the OpenFast GitHub, that has lots of other tools, including like Campbell diagram generation and tools to run OpenFast. And so having all of this in one cohesive package, or at least understanding what the breadth of that is part of the work for this year. The installation process. So we've been working with other people who use Wise quite a bit, and we've seen firsthand how challenging it can be to install these tools on a variety of machines. So that's one thing that we're working through. And that is almost as easy as just, you know, WISE currently requires compiling all of the tools in order to install it, but that's an easy thing to kind of move past and just use the package managers that are already in place. And thanks for the suggestion on the Docker containers. We'll think through that too. We'll also develop a software quality grading and review system. So this is more internal, but it will impact any external developers as well. And of course, we're going to continue the work that we've been doing this year, where we'll refine and expand the portfolio analyses. And all of this will be documented on the WETO stack repository, which is what I've showed, and it's at that link. Okay, now this is the final slide. So that is the presentation. So we can take this time to, if there are any other questions, or I also wanted to reserve some time for just an open-ended discussion. And I personally have these questions for you. And so these can be used to kind of to seed the discussion. So these questions are, where do you see the strengths and the gaps in the WETO software portfolio? We've already addressed one, which is kind of an accessibility thing. But if there are any gaps in capabilities or technical areas, I'm interested to know that, as well as other issues around usability or accessibility. And then finally, regarding the WETO software portfolio, what is appealing? Like, why are you interested in it, and why do you come to it? And what do you see that is currently lacking that is maybe not addressed by the first question? Go ahead. Mhm. Yeah, so it sounds like defining the envelope and communicating that. Okay, yeah, good idea. Mhm. Can you, yeah, what kind of documentation do you find most useful? Example scripts or theory documentation? Both?
Software development into C++. But yes, just there's basically no documentation, so
Yeah.
explaining what's going on. It's very simple.
Okay, yeah, thanks. That's of course something we've heard quite a bit, and we had this effort to, a lot of projects had an effort to as a kind of a stopgap, to publish examples and tutorials that aren't necessarily text-based or maybe code-based documentation. But it sounds like maybe some combination of the two would be useful, especially for somebody totally green getting started. All right, thanks for the feedback. The examples are the most useful thing.
Yes.
All right,
thanks.
Follow-up question. Like some of our tools have sorry, I almost went off. Some of our tools have like sort of upwards of say 20 or 30 examples. And sometimes that's just numbered out 0 to 30 with maybe a title that's hopefully a bit indicative, but how like well organized do examples need to be sort of like easy to access, easy to find?
I mean, more winning stations, obviously better, but, you know, there's been some that, you know, you have a good time, sometimes that's all you need.
Yeah.
You know what software you're using, you know the general use case. So a lot of times it's just getting it up and running, you want to see, you know, file structure and just how to run it. Like that's, and maybe that's just for people, that's the easiest way to learn something versus, you know, reading documentation.
Yeah, yeah.
We talked about it, things tied to that is, we have, a lot of the tools have like this regression test package, which is really trying to just make sure that code is producing the same answer every time we change it and file it. Then some codes have also like a samples thing that's more like we can like, okay, if I want to do this, here's a good thing to show how that works. And then maybe we just need to be better at that, like split out, like here's the pure testing. Maybe we should try to say, well, every sample we need a regression test, but then the test gets so long that it takes forever to do them, and
Yeah.
so I talked about having some relation like that. And so I think some codes do it well, some don't.
I think what you're getting at, or at least what I've felt, is just the practicality. You know, you have a short time frame and you just need to do the thing, and so you have a test case and you throw it in the regression test, and it's kind of, you know, it's almost good enough. But yeah, good feedback. Go ahead. Yeah.
Like, this is what's happening here,
Yeah.
and then like code. In the sense that, and you don't need much, like, you
Yeah.
really only need maybe one per tool.
Mhm.
Yeah, a tutorial, it's like.
Well, it sounds like there's, yeah, like a tutorial, which is kind of the onboarding. And then the examples are, once you're at a certain level, once you're in 5th grade, now you can go on and go figure it out. Yeah. Okay. That's good point. Go ahead. Okay. Yeah.
What the package came to and that will not going to learn what I was thinking.
Okay. Yeah, that's great feedback. Thanks. Okay. Yeah. Yeah, I don't know if seems like this is just not working, but we've in Florist, we've used this framework called, at least one version of it is called diataxis, and it breaks it out into how-tos, references, tutorials, and explanations. And so Florist also has a similar thing as PyWake now, and I think it's quite useful, but we can, you know, we still have yet to kind of move that over to other projects. Oh, yeah.
Would you have direct HDMI or no?
No, I'm using that.
Yeah, okay. In the end, like I had to go direct HDMI, but you can try that.
Okay, next time it bugs out, I'll do it. Yeah, so we have this for Florist, and this is meant to be that sort of like onboarding tutorial thing. And then we have a list of examples, and this doesn't show the example code, but it gives you kind of a reference on where to go. And then we have, this is more of the developer reference, so you wouldn't read through it all, but you would maybe go to that if you have a particular problem. And this is also still a work in progress, but is this more or less what you're talking about? Okay. Cool. Okay. Yeah. Yeah, thanks for that feedback. It's really helpful to hear that this is important to you, you know, because then we can kind of adjust how our priorities are. Go ahead. In the slides. Oh, gosh. Yeah. Yeah, I mean, yeah, that's a great idea, and I'll add that to the best practices because that is almost it should become a standard nowadays to just if you have some analysis script to put it on the internet and especially tag the versions. I know that for a lot of tools that's a major issue. So yeah, good point. Yeah. Yeah, exactly. Mhm.
Maybe, ask about cows.
Mhm.
And this perhaps this should start with the question, right? Does WETO support, what does WETO support in terms of the software-based mission? Is it meant to be more of a research and pedagogy, but teachable to people about fundamentals of modeling and simulation, and also at the same time research is providing new computational techniques and really fast tools that would help industry get their time to market by X%. Is that part of the mission? You don't agree to that?
It would be nice if someone from WETO were here to answer that. I've got my interpretation of it. Maybe Jason has his own, so you share too. But I'll just say that my understanding of this question, first, this is something I've also been trying to really nail down. And my interpretation is that it does go back to the mission that I stated at the beginning, that if there is the use case to speed up something for industry, and that'll really enable wind energy adoption and expansion, then they might support it. And on the other hand, if it enables new research, that also is something that they support. So it's almost the both and rather than the either or. And but it's up to us to propose and them to fund. Jason, do you have anything to add to that?
I hate to say it, that's not important, it's gonna do that. We always have to write a proposal, get money for projects, and usually software is like it needs to win. A lot of it's very viable for the community, maybe it helps, but it's not, really like in the project's description. We do a lot of industry work these days, which I think tends to fill in a lot of things that we're not researching for projects, but we're needed to make this tools successful for industry applications. I think there's some disconnect there, but I think like open fast, I would say there's lots of great documentation out there, but it's not all consolidated in nice, here it is. It's like you have to go there and there and there. And that's, I think this based on the way it's funded. And I'd love to just say, let's go just clean all that up and make it here it is. But I can't make this a proposal to be sold. But so we're kind of relying on like the community, right? The community, industry funding and so on. It's to be like, we have like a roadmap of all these things we want to do. And I have to sort of find out which project can fund each part of that program. I think that's the challenge we're always facing. Software, I think it's just that.
It's a really mechanism for a company that wants to start getting, deeper result, deeper into it to come in fund projects.
Definitely, I want to make sure that's clear too. Yes, so like, at least the third way it's not right now is industry projects. That's probably pretty consistent across all the software space. So yes, I mean, there's mechanisms to make it happen. US based, it's really easy. How much money you want to spend on what, just make it happen. If it's a foreign based company, yes, it's also possible, but it is a bit harder. Because we are like a government contractor you need government approval for things, so that, like, here from Europe, it's not generally no big concern, security wise, but there's a world to make it happen. So what that really means, so European companies, is that there's really a threshold, like below that, it's not really worth the efforts. You have to make it as, a sizable project. Then there's also like, there's Iran or terrorist countries, and it's like, whatever. Anyways, so then there's a sort of range of options.
And this is the TCF, is that right? Or are there other?
No.
Oh,
Collaborations.
okay. Okay, so there's two options. TCF would be one avenue, but that's a more formal and has a process where they do a call for proposals, right?
Yeah, it's like the other way around. Saying like, we have an idea that we think industry should take advantage of.
Yeah.
It's part of the mainstream, and then they can get government funding and make that happen. And then the other way you were asking, like some company X wants to, add some capability fast or fix this thing that's not working. Then we can make that project get like right support. Technical support is I still need help in the first one. It's a big piece of software that I can't do it. I can get into my business workflow. We definitely do that. Yes.
You asked for capability of one, just, I think, speeding up the decalculation that usually you do for the system.
Okay.
Having abilities to swap out things that are not really like a vibratory model.
Mhm.
If say, for example, the fastest speed is modular, we don't want this. Whether they are of standardizing bases and stuff, like you're doing with the diode, things like that. If we can propagate it to the tool set and say, if somebody wants to swap out their one drivetrain.
Yeah.
Using, say, like.
Yeah.
And then it becomes a modeling platform.
Yeah. Right.
In general, a video on board, say, more people start using it as modeling,
Mm-hmm.
not just as.
Yeah. Yeah. Okay. Good ideas.
This maybe data, directly from the field right now, only applications are working. Right? That's
I think there's a couple others, MOA or Hercules or MOA, maybe taking some other field data. But anyway, yeah, I think those are the two main ones. Mm-hmm. Okay. Okay, so it sounds like standardization of data in general across models. Yeah. Mm-hmm. Yeah, we've got a WindIO meeting later today, and I wonder if that's the right venue, the right mechanism for that, or if that's something else. But I think OpenOA and what's it, Enter has been working on this. The adjacent fields. Yeah. Right. Yeah. Okay. Good. Yeah. Good suggestion. Thanks. Okay. Well, if there's anything else, bring it up. Otherwise, we can wrap up and give you some time for coffee. I'll be around the rest of the day, so please engage if you want to chat. And I'll just say once again, the repository here, github.com/nrel/WETO that's meant to be a living thing. If you have these suggestions, feel free to open an issue, post a discussion, make changes to the documentation, make it your own. This is not my thing, it's our thing. Go ahead, Misha.
Like how we better produce that software, but like you feel like there's actually technical gaps.
I think there's a lot of duplication. For example, we were just discussing here, what is the difference between WinDSE and FastFarm? Yeah, I mean, we know the numerical difference and the modeling difference, but in terms of how we use it, Jason nicely explained it, and that's probably the best I've heard it yet. But communicating that broadly across the portfolio would be very useful. I think that's the missed opportunity yet, as far as a collection of software tools. And I think the impact of that is that then we end up with situations where there's a lot of duplication. We like that situation I mentioned where you have to install Wisdom to use one submodule of Wisdom that only reads OpenFast output files to use all these other tools. You know, that is the sort of thing that we really could streamline and just make all of our lives easier. Both I mean, the developers use these tools as well. So that would make our lives easier, as well as all of the community of users' lives easier. So I think that's the biggest gap that I see, and that's why I'm really interested in this project to begin with. It's kind of an opportunity to address this low-hanging fruit on the technical side. Uh-huh. So you pip install Florus or the tool, and then you separately download the repository to get the examples. Okay, I see. Hmm. Yeah, that's a good point. That is a catch-22 yet. If you want the examples, you have to clone the code, but if you're not comfortable with the command line and Git and all this stuff, how are you going to clone the code? So. Yeah. Go ahead.
What would be a good mechanism? What would you like what would the users feel comfortable? How many people are actually using it? Like, Angular, and how well is it used? Downloads just to be student interested, right? For a week and
Yeah.
or does it finish the home problem for the project and it's done. There will be serious users trying and working with it. You great to, I think, as a community, get a distinction to say how much and what kind. Get the feedback, and within the user community, you get like, okay, at least one small benefit in the capability, or what would you love to, what would you like to see?
I'll say from my side, nothing makes me happier than when somebody engages on GitHub. The discussions, the issues, the pull requests, it means that our work is not for nothing. You know, we're not just writing code to write code. We really want to have an impact in wind energy for a reason. You know, we're all passionate about this. So when people use it, it just feels good. You know, it's probably the way that an artist feels when they put something out and somebody's like, oh, it really meant a lot. So that, and as far as tracking usage metrics, yeah, good question. That's something that we'll think through and come back to you on the user workshop. But but that would be extremely helpful as well. And I know there's challenges to that as far as privacy and IP and so on, but just reducing those barriers would be really helpful for us to know who's using it, and so that way we can take that to our funders and make a pitch. Yeah.
Sharing it, you just shared it.
Yeah.
Do you have any ideas how we can solve that? How we can, if they are willing to share, how can you kind of make them do that?
Yeah, well, I guess it's two things. One is sharing that they're using it, first of all. And I made a show and tell section of the discussions, hoping that people would post there, but I think it's maybe that's not that appealing. This is for florists, by the way. So it's one thing to understand who's using it, and maybe that's more of just a number or kind of informal relationships. I don't, if you have any other ideas for something more tangible, I'm open. But on the other side, the contributions of code development, that's again, with florists, that's something we've been trying to address. So we've spent quite a bit of time trying to streamline even the internal APIs. We've added internal documentation, and we've tried to just make it more extendable. So I added some diagrams on the architecture of florists, which was the one that I showed right here. And actually somebody over the summer gave us a huge pull request that we had no idea. They didn't communicate with us to do any of that work. They did it all on their own. So I think the efforts are paying off. We're certainly not there yet, but I do think reducing that barrier will hopefully encourage people to give it back. My other thought is just that establishing this user community, which will be primarily at the workshop in May or June, hopefully we'll get that word out. And I'm also hoping to continue talking about this at conferences and so on. Yeah. Oh.
Is this something you could very simply put in the kind of GitHub README, whatever?
Yeah.
Right? There's exactly all the instructions of how to install it and how to use it. But I think currently it makes clear that there's a value for you to know that we're using it. It's a good point to be quick display.
You have a form or something that says, what do you use it for?
Mm-hmm.
And in the end, when it goes into the database, don't have to putting names and attributes. You just go in and pick, here's a large number of operators that has information to bring back, so we use to florists. That's all the world needs to know. They don't need to know who it was.
Mm-hmm.
You guys have any like newsletter or something like that where you're constantly engaging end users, and that can be, you can have polls and surveys in there.
Mm-hmm.
That might help you get a better idea.
Yeah, the florist teams that newsletter regularity, certainly at every, and that's kind of up to each team. That is something I was thinking about with regard to this holistic modeling project. Well, two things. One, making that website some sort of front end for any news or anything. And secondly, some sort of broad strokes software portfolio newsletter. But yeah, right. Yeah. Aside from those things, do you have a suggestion on what you'd like to see? Mm-hmm. Yeah. Okay. That's a great idea.
Yeah, mentioning. Yeah. Both updated a year ago, but it's still like supposed to be open fast, but I'm supposed to do for software, and the rules, gosh. Things open fast, it's probably how it's split. Yeah, before, 20 years, you in there, do stuff, go to get done, just the ball, wow, it's like, Teams or Slack or stuff like that, to communicate. So somebody's online and ask a question there in public. And then you post it, waiting first.
The benefit of GitHub in general, the reason I'm really partial to it is because it's searchable, and that I use that even when I'm trying to find some answer, especially for somebody else that I know I've answered in the past. I'll just search for something, and so something like, well, Discord or something like that is also searchable and might solve that same. Yeah. Yeah, good idea. We'll think through that both at the project level and just broadly at this holistic modeling level. I guess a summary seems like there's maybe some technical challenges, especially with data. Well, first of all, accessibility, and then there's the data consistency across domains and across tools. But I'm hearing a lot of just engagement, that the engagement could be better, the documentation, the information sharing both ways. Does that sound right? Okay.
Projects
Uh, Loosely, I think this varies by project. It's more about the kind of culture that each project has developed among their team. And as a lab, well, I guess I shouldn't speak as a lab, as a center, as the National Wind Technology Center, there have been a lot of efforts to kind of elevate the elevate the quality of software that we are producing. And this is part of it. Most projects these days do have some sort of automated testing. The continuous integration, or the automated resources are effectively free these days on GitHub. So we've been encouraging people to just use and abuse them and kind of not think about the computational costs. And that, I think, has added a lot of that. You can, when you submit a pull request to incorporate some code, you get a red X or a green check if you've passed some tests. And that's certainly one step. But I think there's always work to do in this regard. And that's both a training thing, but also us also just finding the right balance of testing and validating something to a certain degree, but also managing the rest of the stuff that's required. Like Jason said, the software development tends to be a means to an end, and that end is typically some sort of analysis for some work or a publication. And so it's quite easy to get your figures and let it go.
Yeah, I think.
Yeah. Yeah.
Yeah,
thing that WETO is starting to like reinvent, probably spearheaded by over the past,
Yeah.
plus 15, 20 years, but like now I think WETO's, I think it's true that we are like kind of constantly struggling with this, but I think kind of getting direction, that I think the tools themselves are better.
And for what it's worth, the best practices that I have listed on this site, that this year was I built it as a proposed set of best practices. And then in the current year of this project, I'm trying to get developers and model owners on board with those to adopt them. So it's a bit of an iteration process. But then for the third year, my intention at least is to really hold ourselves accountable to those best practices. And a lot of it addresses what you're referring to now. Go ahead, Corey.
Take that. I have a question. Your experience talk about it, professionals and user focus software and real software.
So to some degree, yes. And this is something that I'm actively interested in. I've been actually having a lot of conversations around here along the same topic. So what I've landed on so far are highlighted in the best practices. So that document is tailored specifically to research software and my personal experience in developing software at NREL. So there's some things like because extendability is a key component to keeping a software project alive, you can't do anything complicated, because then if you yourself in a year don't know what that means, or someone else doesn't know what that means, your extendability is shot. So simplicity is a high priority, but that necessarily limits what you can do. A tangible example of this is in Florist. We went through a redesign of the whole Florist architecture because it wasn't leveraging the whole CPU register at a time. It was a poorly posed data structure. And so we redesigned it to leverage SIMD calculations on a CPU. And there's a ton of libraries in Python to do this sort of higher performing math, one of which is Xarray. And we evaluated Xarray, but we decided that the syntax was too strange, and that it would be too much of a burden for ourselves to come back and relearn this every time we want to do a new effort and have new people train on Xarray, even though we probably could have gotten better performance. So we made the choice to stick with NumPy because it's fairly ubiquitous, even at the expense of some computational costs. So I think that's the sort of thing that are nuances of research software specifically, and I think that's a function of the funding mechanism and just the way that these projects work. But I'm sure there are other considerations, such as verification and validation. I was talking to somebody last night about Wiffle and their whole weather forecasting suite and what their V&V are, and it sounded like it wasn't, as like published and front and center as you would for research software. So that's another, I guess another perspective or data point. But yeah, I'm really interested in this. I think I've thought through and talked to some people about whether there is an avenue for somehow commercializing some subset of the software that we have and licensing it or something like that. But it seems that that might be outside of DOE's lane, so to speak. And I think there's a lot of value in somebody doing that, taking the tools that we have and making them super robust, maybe don't add any features, but just make them work every time,
Yeah,
Yeah.
Exactly. They're like, oh yeah, I'm like a much more scientist now.
Hmm.
Someone basically is like, here's the framework, this is the part that you put in,
Yeah.
and you put that in, and then you have time to concentrate on, like, how to deal with stuff and not so much time. The memories, like, set up and getting documentation, like, maintaining documentation.
Yeah.
All these other kind of tasks.
Mhm.
Yeah, I wonder if there's like a model where, you know, yeah, I guess it all depends on what DOE wants us to be at the end of the day.
Yeah.
But I imagine there's probably a lot of support and documentation and other things we can do at a level that are more professional, I guess, like, not that we're not being professional.
Yeah, that next level, you know,
In and of itself.
yeah. Going from research software to professional software, I think.
Exactly.
Yeah, let's talk more about that too. Let's keep that conversation going. I think there's an opportunity there. Okay, we should wrap up. Thank you, everybody. This is recorded. I don't know exactly where it'll be hosted, but I'll send a follow-up on that. And I really appreciate the conversation. This means a lot to me. And if you want to stay engaged, please reach out. And thanks, Derek. Sorry. What's that? Oh, it's huge. Presentation was great. I don't know what Teams is doing. Oh, here. Yeah, right. That's it.
Yeah.
Hey. Yeah. Let me just wrap this up so Jason can get set up. And then